Okay, so now we'll finish some other things, and we'll come back to our osmosis activity. So what are we testing here? We know, is water going to pass through this membrane? Yes. So, but what are we testing? We have water with iodine in the bag, or in the speaker, and in the bag we have starch and water. So we're testing to see if starch will diffuse across this membrane. We know water will. We want to see if starch. So I kind of bring this up. I'm seeing a little bit of a reaction there. I can see. So in here, the rest of the starch mixture. Okay. The last part says, while you're waiting, add 8 drops of this iodine into the starch mixture. So as we come and look, so if we add iodine to this starch, you see it turns pretty dark. Now, as we come and look at this, is this getting darker? Yes. Is it the same? No. So right now we're going to test to see what selective permeability does this bag have for starch. So, how does osmosis work? So we have a concentration here of water on each side of this. So if we have the cell membrane here, we have a concentration of sugar solution on each side. However, osmosis only deals with water. So we're not going to deal, the sugar is not going to go through the membrane. We're just looking at the water. So you see the red is the sugar and the blue is the water. So we see that there's a lower concentration of water here than there is here. So there's more blue here than there is here. So through osmosis, what occurs now is this water is then going to cross this membrane and add here. And as you look at this side, this volume went down and this volume went up because water wanted to cross from this side over to this side. And that's what that's showing right there. So when we talk about osmosis, we're only talking about water. So the water concentration here is different than the water concentration here. As we can see, there's more red here, so there's a more concentrated sugar solution here and a more dilute or more watered down sugar solution here, meaning more water here than here. So through osmosis, this water concentration here is going to equal this water concentration. And we can see the difference then in the different levels. So these water molecules will move until the water concentrations equal one another. Osmosis deals with water only. If the sugar molecules diffuses across, that is diffusion. But if it's just water, then it's osmosis. So make sure diffusion is any molecule going across. Osmosis is diffusing water across the membrane. So if we were to change this, so we have a certain solution here that's changing. So we know that in this solution, we want to try to have the water equal the sugar, but that might not occur. So when we talk about diffusing water across membranes, when water and other molecules are at equal concentrations, that is what we call isotonic. Iso means equal. Tonic talks about solutions, so equal concentrations is said to be isotonic. So isotonic is going to be normal. That's what cells want to be. They want to have equal solutions. The cell is going to occur, or is going to work normally in those conditions. But when we add the concentration and the concentration gets to be a lot higher, then we're said to be hypertonic. So as we add the water molecules from this side over here, this solution is what we're going to call hypertonic. Now in some instances, that's okay, that's needed. But what happens if we just keep adding more water, more water, more water? Things swell. You add water to a balloon. Keep adding water, water. Eventually, it's going to pop. So at some point, for some situations, it may be good for a cell to do that. But if it keeps occurring over and over, it doesn't stop, the cell could burst due to increased water. So that's hyper. Hyper meaning more concentration. Lower concentration, hypotonic. So in that other situation here, we have, so this solution here is becoming hypotonic. That concentration is decreasing. So as that solution is decreasing, at times you're going to, if cells do this, they're going to lose their shape. So on the next page, on the page opposite figure 717, is when you're going to have this hypotonic state. It's going to show, in that on opposite 717, it shows you the isotonic cell, the hypertonic cell, the hypotonic cell, and shows different results of what can happen for each cell. So make sure we know this. So we have isotonic, hypertonic, and hypotonic. Make sure we know that figure, know what the definition is of each one of these conditions, and then also how this affects the cell. Does it allow the cell to function normally? Does it allow the cell to function abnormally? What's going to happen if it does function abnormally? What's going to happen to it? So make sure we know that. Okay, so now we've got two different types of assisted diffusion. So diffusion at times might need a little bit of help. So now the first one we call facilitated diffusion. How can molecules cross cell membranes if they're not able to cross the phospholipid bilayer? So if these molecules cannot pass through here, how do they get there? They got to enter the cell. There's certain things you cannot contract. You cannot contract any muscle without sodium and calcium. Those cannot diffuse across that cell membrane. How do they get across that membrane? Before we talked about after the components to the cell membrane, we had this phospholipid bilayer. We also had these protein channels. Well, in certain instances, these protein channels will open up and allow these molecules to then enter the cell. So nothing is needed, just these protein channels then open up and allow these molecules to enter the cell. So there's certain things at times that are needed in the cell, are able to do that. So through these protein channels allow these molecules to go in and out of the cell. This is still thought as diffusion, meaning concentration. So as long as the concentration is high here, it's going to allow for these protein channels will recognize that concentration, allow these molecules to enter the cell to try to equal out the concentrations. So it still will follow the principles of diffusion. Even though it's not going through the lipid bilayer, it can still go through the protein channel. Now this next one, a little more complicated, active transport. Active transport is diffusion, but it's a little bit opposite. Molecules are going to move across the gradient, meaning we know diffusion moves from high to low. What about at certain times when things need to go from low to high? How are we able to do that? So we want as much as a certain chemical as possible in the cell. So we want as much sodium as we want in the cell in order to contract our muscles. Without it, you wouldn't be able to walk. You wouldn't be able to walk down the hall, run down the basketball court.